Let's get started. This is going to be the last week of the lecture, actually. So today we are going to talk about two topics. First is internet censorship and anonymous communications. So they are two highly related topics and very interesting. So censorship, we all know censorship is a practice of examining in order to suppress or delete anything considered objectionable. And in particular, internet censorship is about the suppression of internet communication by government or ISP. So censorship, sometimes they have very legit reasons. For example, there are websites, they sell illegal stuff, and the government, ISP, they want to stop that. But most of the censorship we are saying, they are because of some of political, even commercial reasons. So today we are going to look at one of the very, I would say, successful censorship tool is China's Great Firewall. So actually in China, they don't call it Great Firewall. So this is a name given by Western observers, I would say. So basically, it is called the Great Firewall. It is a huge system that covers the whole mainland China, starting from 1998. It focuses on internet security control and especially censorship. So even though they gave the name firewall, it's much more than a firewall. It's a combination of traditional firewall, network intrusion detection system, and also network attack system. So you're going to say later, the attack techniques we have learned in this class has been used in this system. So this system is famous for blocking Twitter, Facebook, Google. So if you go to China, you cannot visit Twitter, Google, or Facebook, or some pages of Wikipedia, or sometimes just some random website you don't know why you cannot visit. And this firewall is a distributed. It's deployed all over China, and it is deployed at the ISP backbone and the international gateways. So all the packets, incoming and outgoing packets of China will be inspected by this system, firewall system. So in this class, we're not talking about political or commercial reasons for the government to do this. We were focused on the techniques behind the thing. And actually, I graduated from a university in Beijing, and our university was leading the effort of this firewall. And I still have collaboration with them, so I don't want to talk about the political or commercial things. So basically, the techniques used by the firewall, including IP blocking. So this is a typical firewall action based on the IP headers, the source address, and destination address, and also DNS injection. So you did this in NAP 5 maybe. So this firewall actually is also an attack tool to inject fake DNS response. And it also look at application layer data, such as content, like your web page, and URL. So it can do URL and content-based filtering. It can also interfere secure collections. So if you are using HTTPS, it will try to block the IP, and it can also record users' activities. So let's look at the details. The first one is IP blocking. So if you go to China, you try to visit youtube.com, you probably get something like this. That is because the IP of YouTube is in their blacklist. So that blacklist is actually dynamic, sometimes based on the agreement between the companies and the Chinese government. They will update those blacklists. And another one, the second one is DNS injection. So those are the true IP addresses of Facebook.com. But if you visit from some cities of China, you get fake IP addresses. But sometimes you visit from Beijing, you can actually visit Facebook.com. So let me remind you how DNS works. So let's say you are a user in China. You set your DNS server as Google's DNS, and you will ask some sensitive website the IP address. So you will ask your DNS server first, and Google DNS server will try to resolve that by first asking the top-level domain server and the other domain servers. And this is how a normal DNS works. So how this injection by this great firewall works is, let's say, the system is deployed at an international gateway. So every packet going out, incoming of China, they can take a look. So if you are in China, you try to visit some sensitive website, and first you do a DNS query, and maybe your DNS server is in China, so it will not be censored, it will not be analyzed. But your DNS server will eventually try to communicate with the top-level domain server. And there are only 13 logical and hundreds of them, and most of them are located, maybe all of them are located at the US. So eventually, the DNS server will send a DNS query to another DNS server at US. And this firewall will be able to intercept that because it crosses this international gateway. And whenever it receives that and it says this is a sensitive URL, it will inject a fake DNS record, DNS response to your DNS server before the true DNS server be able to send back the DNS response. So this problem can be solved. You use DNSSEC. We studied that before, but this DNSSEC has not been widely deployed. That's why this attack still works. But you did a similar attack in your lab, but this is government-sponsored attack. And there is something unexpected of this. So the original purpose was to just censor all the internet usage in China. But actually something of this can affect other countries as well. So let's say you are in Arizona. You want to visit a website which is in Europe. And first you query your DNS server, and you think that one might be in New York. But eventually, that DNS server needs to query another DNS server in Europe. So how is that your DNS query goes from United States to Europe? It may go cross China. So when it goes cross China, the Great Firewall will identify that and try to inject to your DNS server. So this happens. So I think they didn't design it this way because they don't want to affect other countries, but maybe because of a misconfiguration or whatever, it happened. So in 2012, some researchers from the movie Matrix, Spark, Leo, Tech, Smith, so they published a paper. This is a real paper. in SIGCOMM 2012. So they published this paper talking about how the China's Great Firewall has been damaging the whole internet because of the use of DNS injection. So I don't know where other researchers from. I don't know if they gave a presentation in a conference because they use the pseudonym. Obviously, they don't want to disclose their identity. So, so this is actually a serious problem. But but for the Chinese government, they can easily fix this. So if the query is from outside of China, they just maybe ignore that or something like that. So they don't have to affect other part of the world. So the next technique they use is content filtering. So they look at the content of your internet collections, like HTTP, like your web page. So if you are in China, you visit a US website, and that web page has something sensitive. First, the firewall will let it through. Then it will do some deep packet analysis to check if that website has some sensitive keywords. If there is, they will try to tear down this collection. So do you remember how does that work? Yes, so basically the firewall will send two TCP reset to the source and destination. So which means the first time you will be able to get that web page, but later you will not be able to get that again. So they will have a dynamic blacklist and tear down the collection. So this also, they do the same thing for URL. So some researchers find out that in China, you can access wikipedia.org, but if you want to visit Wikipedia, the page about internet censorship in China, you will not be able to access it. But that is part of the application data. So internet censorship is actually a very popular thing all over the world. In 2012, some researchers, they came up with some metrics to measure how free our internet is. So the green part means these countries, they have very free internet, like US, Brazil, Argentina, Australia. And the yellow means partially free, like Russia, India, and this dark blue, purple is like, it's not free. And China is one of them. But sometimes you will be surprised how modern China is, but our internet policy is just ridiculous. Our internet policy cannot match the civilization levels here. But
Canada, no data.
No data, I don't know. This is 2012, yeah. Yes. So basically in China, you cannot visit Google, Facebook, Twitter, but we have all the Chinese counterpart of those websites. And sometimes they are even bigger. I think the Chinese Amazon is much bigger than Amazon. And Chinese WeChat might be bigger than Twitter. So that's why I'm saying some of the decisions they make may not be based on political reasons, might be commercial reasons. We just don't know. Yeah.
Is it common for people to get around that though? Because I've
Yes.
heard a lot.
Yes. Every time I go back to China, I will use a VPN to access my Gmail.
So why don't they stop like VPNs?
So they can't. That's why I think sometimes it's not really political, it's commercial. They don't want to go that far to stop everything. Yeah. Hard to tell. Yep.
And another thing too is they also want to be aware of what's going on the internet outside of their internet too. So, I mean, completely being blind about what's going on in the U.S. or France or any of the other countries would be not very smart.
Yes. So it's not isolated. They just want to build a wall there. Okay. So if you feel good now, you think U.S. is a free country. We have a free internet. So I have to remind you of Edward Snowden. So anyone here doesn't know Edward Snowden? Never heard of Edward Snowden? Okay, that's good. So John Oliver, he had a very good episode about this government surveillance system prison. So I don't know if you have watched this. If not, go to this link. It's a terrific episode. I think it's his best ever. Actually, so to do this episode, he flew to Moscow, Russia, to talk with Edward Snowden. So what Edward Snowden told us is something very interesting. Is the U.S. government is actually having a similar thing like the Chinese government has, but they are not using it for censorship. They claim they only use it for surveillance. So basically, they also deploy some system at the international gateway. So all the packets, incoming, outgoing of the US will be inspected by their system. So you may think this is not a big issue because you only visit US website. So this is what Edward Snowden told us, which is not true. Let's say you are in Phoenix, you want to visit your Gmail account, and you think that Gmail server might be in Washington or Silicon Valley, but it may not be true because Google has web servers and data centers all over the world. You don't really know where your data is stored. It is probably stored in Europe, Japan, or Australia. So whenever your data across the internet gateway, NSA has a copy of your data. So, so I suggest you to watch the John Oliver's video. Actually, he used a very, anyone watched that video before? Oh, you watched? Yeah, it's terrific. He used a very good example there, but it's not appropriate for the class. So yeah, but it's awesome. So how can we defeat this kind of censorship? For the DNS injection, what we learned is we can use DNSSEC. And for those content and URL filtering, we can use HTTPS to encrypt the data. But still, they can block the IP address. And in some countries, it is reported that the government is even blocking all the encrypted internet traffic. This is like 2012. So I'm not sure if they are still doing that. And another way to do this is use VPN. Different from HTTPS. HTTPS, you cannot protect the IP headers. So you can use a proxy or VPN to encrypt everything. So from the international gateway, we only know that you are talking with this VPN, but it doesn't know which website actually you are talking with. But this can also be brought. Yeah.
You showed us that sometimes our Gmail or whatever might be stored on a server somewhere else. Then is that server, do they have like an agreement with the government? Like how do I know that the government of Australia isn't just going to go and...
I don't know. You have to read the 200-page Edward Snowden report.
Yeah.
Yes. So every time I go back to China, I will use a VPN to access my Gmail account, and usually those services are not free. So that's why the second topic of this class is about a free service called Tor. And even though Tor was not built for bypassing censorship, it can be used this way. So Tor is actually built for anonymous communication. So anonymous communication means in the internet, you want to conceal your identity. You want to visit a website, but you don't want the website knows who you are. And you don't want everyone in the middle knows you are visiting this website. So this is different from confidentiality, because confidentiality is talking about the content should be secured. The content should not be eavesdropped. But anonymity is about your identity. However, internet anonymity is very difficult. That is because the protocol we are using, TCP/IP, the source IP address and destination IP address is in the IP header, and they are used for routing, and they has to be plain text. Otherwise, the routers don't know how to send your packets. So the basic idea to achieve anonymous communication is somehow to ask someone to send the data for you. So one way is use a proxy, but which means you have to trust that proxy. So Tor moves a little bit one step further. It uses multiple proxies, a lot of proxies. And those proxies, they form a P2P network. So when you are using a Tor client, you can also serve as a Tor server to relay data for someone else. So this protocol was proposed in 1998. So basically, how it works, so user U wants to talk with the destination D. So this may be you want to visit a website which has IP address D. And first, your Tor client will try to generate a path from you to the destination. And that path may have arbitrary numbers of proxies. So these proxies are not the network routers. They are at application level, try to relay data for you. So let's say if your client discovered, generate a random path from 1 to 4 to 3, then finally to website D, then your client will try to use this path. So how does it use it? So let's say your client tried to send a message M to the destination D. That message M could be a HTTP request. So first, your client will encrypt that message using node 3's public key, then node 4's public key, and eventually node 1's public key. It can do this because it calculated the path in advance, and it can get all the public keys from those nodes. Then it will send this message to node A. When node A receives this message, it will decrypt it using its private key, then find out, oh, this is a message for node 4. So it will forward this message to node 4. And node 4 will identify, oh, after decryption, will identify this is a message for node 3. The node 3 will decrypt it and eventually send it to D. So the path is arbitrarily long. And also, so you can see that, let's say node 4 here, it only sees this encrypted message, and it can decrypt it, but it doesn't know if node 1 is the originator of this message, or node 1 is just forwarding this message for someone else. It doesn't know the existence of a user. And it doesn't, because it doesn't know, it cannot say the message itself, because it doesn't have node 3's private key. It doesn't know where this message is headed to. In this case, it's to D. So every node here only knows the previous node and the next node. They don't really know the original initiator of this collection and the destination of this collection. So if some of the nodes are malicious, they try to disclose this information to else, they can only see part of this message. you can see only part of this path, this circuit. So this is called onion routing because this is encrypted multiple times, layer by layer. So this is basically how it works. Any questions so far? Yeah.
So this is like peer-to-peer, you said?
Yes. So the network is peer-to-peer.
So if no one is associated with D, then potentially you would never reach that site then? Or,
Can you repeat that?
so if like four, say none of the nodes ever like visited that site or whatever, you could potentially never see that site because no one would be associated with it.
So I'm not sure if I understand your question correctly, but here, like node 4 knows this package is eventually going to this website, but it doesn't know where it is from. It only knows it from node 2, but node 2 is not the actual initiator in this case. Yeah. Does that answer your question? Okay. So it's also possible that all those websites, they are just under Tor, but that will be the topic of our next lecture. So usually that is called darknet, and a lot of illegal things going on there. Yeah. Any other questions? Okay.
Okay, so like in this example, since one is malicious, they would know who you is?
Yes. In this case, yes. But still, node 1 doesn't know if you is really original here, because it's possible you is just forwarding the packets. So there has been a lot of research on this onion routing, try to identify users' identity based on a lot of models, but that's very complicated. So if no other questions, we will talk about the quiz really quick. Okay, so we had a quiz last week. So the first question is, which of the following statements about network DMZ is wrong? So the answer is A, because there is no rule saying that attackers cannot do what. So B is correct. DMZ and an additional layer of security to an organization's local network, because it's kind of like a buffer in the middle. And an external network node can only access what is exposed in DMZ, and the rest of the organization network is firewalled. So usually the organization will put their web servers at the DMZ. So this one is A. The second one, a packet filter firewall usually doesn't look at application layer data, but this is usually. So the firewall, the great firewall, we just took a look. That one will look at the application data, but that is not a traditional firewall. So they will use transport layer, like the port numbers and IP addresses to filter data. So the third one, which the following about the stateful firewall is correct. So a stateful firewall can identify fake IP addresses. That is not true. So all the firewalls, they are relying on the IP addresses. So if that IP address is spoofed, they cannot identify that. And the B state firewall can remember the collection states. That is correct. C stateful firewall is easier to implement. That is wrong, because at least you have to implement the state transition machines for a stateful firewall. And the stateless firewall, you only need to look at each packet headers. Question 4, a system monitors traffic in and out of network and alert when suspicious traffic occur. That is called an intrusion detection system. I think everyone got this one. 5, which of the following is true of signature-based intrusion detection system. So the A, they say, they alert administrators deviations from normal traffic. So when we use the word normal, which means they are building a profile to say which traffic is normal, which is abnormal, and those IDS are anomaly-based IDS. And the signature-based, they are just looking for strings or maybe strings with wildcards. They can identify previously unknown attacks. That's not true because all the signature-based IDS rely on signature, and you generate signatures from previous attacks. And the anomaly-based, they probably can identify some previously unknown attacks because they have a profile of normal traffic, but they have very high false positive rate. Question 6, which authentication mechanism is easiest to deploy? So the answer is text-based. That's why it is still widely used. All the websites we are using text-based. Question 7, which of the following about Kerberos is wrong? So Kerberos doesn't use asymmetric key crypto. This is just something you need to remember. So technically you can come up with enhanced Kerberos or whatever, use asymmetric key crypto. But the original one, they are not use asymmetric key. So A is correct because there is a trusted third party in Kerberos, and that trusted party knows all the users and all the services in the usually the enterprise network. And the purpose of Kerberos is to support a single sign-on in an enterprise network. So that one is correct as well. Question 8. So biometrics is a method that uses physical traits such as fingerprints, face recognition. Number 9, why it is possible to set up a fake base station to send out short messages. So in GSM, only cell phones are authenticated. That's because the carriers, they have to charge the users, so they authenticate the cell phones. However, the base stations in the original design, they are not authenticated. That's why you can set up a fake base station. So the last question, which statement about anomaly-based intrusion detection is wrong? So they are all correct. Anomaly-based intrusion detection, they have a relatively high false positive rate, and they are using machine learning or data mining to build a profile or model of traffic, normal traffic. And since they are using machine learning or data mining, so they are sometimes called statistical-based IDS. Any other questions? Cool. So Wednesday we will talk about .NET and some other interesting things.